Hello everybody, this is Mr. Roach and welcome to math class. In today's lesson, we're going to learn how to multiply whole numbers using partial products. We will connect this method to the area model, which helps us see how multiplication works, not just memorize it. By the end of this video, you should understand how partial products comes directly from the area model and how both connect to place value. So let's get started. When we multiply two numbers like 23 times 14, we can think of it as finding the area of a rectangle. Each side of the rectangle is broken down into tens and ones, just like we did using the base 10 blocks to build the numbers. That's why this is called the area model. It helps us to see how each part of the numbers contributes to the total product. The partial products method is just another way of writing the same thing using numbers instead of boxes. So let's walk through this both together. So let's take a look at that 23 times 14. Using the area model, we would decompose the numbers into tens and ones, multiply or find the area of each box, and then add them together. Partial products is going to have you multiply the numbers without decomposing them. So we're going to write them like we normally would with the standard algorithm and do 23 and write 14 underneath that. Without decomposing the numbers, I want to multiply the 4 and the 3. 4 times 3 is 12. Next, I want to multiply the 4 times the 20. Well, 4 times 20 is 80, so I'm just going to write that underneath. Next, I want to move to the tens place, and I want to multiply my 10 times 3. 10 times 3 is 30. And finally, I want to do my 10 times my 20. Well, 10 times 20 is 200. Once I multiplied all of my parts, I want to add my products together. So 2, adding in the ones place is 2. 10 plus 80 plus 30 is going to give me 120. So I'm going to write my 2 there. And then 1 times 2 is 300. So I get the answer of 322. Now, if you're paying close attention, you'll notice that my partial products match the boxes in my area model. See how the area model and the partial products method both show the same 4 parts. Each partial product represents one of the smaller rectangles in our area model. Let's try a bigger example. How about 312 times 24? We'll use the area model first to visualize and then move to the partial products. Here, we're going to write it out like a traditional multiplication problem with 312 on top and 24 at the bottom. With my bottom number, I want to start with the ones place. So I want to do 4 times 2, which is going to give me 8. Now I want to do 4 times 10, which is going to give me 40. And then 4 times 300, which is going to give me 1,200. Now I want to move over to the tens place and do 20 times 2, which is going to give me 40. 20 times 10 is going to give me 200, and then 20 times 300 is going to give me 6,000. Now all I have to do is add them all up. In my ones place, it's just 8 all the way down. In my tens place, I have 40 plus 40, which is going to give me 80. In my hundreds place, I have 200 and 200, which is going to give me 400. And then my 1,000 plus my 6,000 is going to give me 7,488. Again, if you pay close attention, you can see that all of our partial products here match our area model here. In the area model, each rectangle showed one part of the product. We could see how the tens, hundreds, and ones combined to make the total. In the partial products method, we use numbers to show each of those same parts without drawing. Both methods help us to understand that multiplication is about combining groups based on place value. When we add all the partial products together, we're finding the total area or the total product. In summarizing what we learned today, the area model shows how multiplication connects to the area and place value. The partial products method records each part of the multiplication using numbers. Both strategies help us to understand why multiplication works, not just how it works. And now it's your turn. Now you can try using the partial products method. Again, you can always use the area model to draw out your next multiplication problem, and then you can see how they match up perfectly. Thank you for taking the time to learn with me. So see you next time.